Hello viewers, my name is Kasumba Jackson. I am going to take you through this second lesson of math. Yesterday we were looking at changing common fractions to recurring decimals. Right now to decimals and then to recurring decimals. Right now we are changing recurring decimals to common fractions. So it's like a reverse. We are coming back. We are coming back. Supposing we are given an example of a recurring decimal. By recurring decimal, yesterday I told you it is a kind of decimal that doesn't seem to be stopping, that continues either with a single digit or with two digits. But we are going to give ourselves the first example as 0.3. When I write another 3 and another 3 with 3 dots, it means this fraction doesn't have an end, so it is a recurring decimal. When we are given a question like change 0.333 recurring to a common fraction, common fraction. How do we handle this? We just take a note of this fraction. A common fraction, I mean a decimal fraction which has no end, which is a recurring decimal, is handled in a special way. Here we are going to use a method where we are going to be creating an equation, and we shall let the fraction that we are going to change to be, let the fraction or the common fraction be an unknown. Let the fraction be m, for example. If the fraction that we are going to change it to is given m, we all know that that fraction must be equivalent to our recurring decimal. So we let our fraction m be equivalent to the recurring decimal, which is 0.33 recurring. Now that this is m, we would like to move our decimal point to the first recurring digit. So our decimal point to go behind the 3, we shall multiply by 10. When we are multiplying by 10, since we have already created an equation, the fact is in equations, we normally, what we do on the other side must be done this side. So we shall multiply 10 on this side such that we get 10 multiplied by m. And this side we shall have our 0.333 recurring, also multiplied by 10. There. So when I get out this, it will be 10m. This is my product this side, which will be equivalent to, when you multiply a recurring decimal by 10, our decimal point will move one digit to behind there. So we shall have instead 3.33. The non-terminating will not go away, but the decimal point will change place. Will change its place to be behind 3. So now that we have two equations, I can call m, this one as my first equation, and I will call this one, which is 10m, as my second equation. So what I'm going to do on my next step, you'll find that we shall be subtracting equation 1 from 2, which is 10m. Our equation 1, equation 2, which we must start with, is 10m, which is equivalent to 3.33 recurring. We are taking away equation 1, which is m, being equivalent to 0.33, also recurring. So when we are subtracting here, you will note that this side we have 10m, we are taking away only 1m. When you subtract 1m from 10m, you bound to remain with 9m, which will give us this side. Then we can also subtract normally. What is 3 take away 0? 3 take away 0 will give us a 3. Then the decimal point must be respected in the line it is. 3 take away 3 is going to be a 0. 3 take away 3 is going to be a 0. So 9m is equivalent to 3. Because 0.00 is the same as 3. Now, the next step will be dividing both sides by 9, because we want to find a single m that is representing our common fraction. So we shall say 9m is divided by 9, and 3 is also divided by 9, because what we do on this side must be done the other side. If it is an equation, 9 will go with 9, I'll remain with m. This is 3 out of 9. My fraction is 3 out of 9, but I must simplify it. 3 out of 9 can be simplified to give us a simple fraction, as if we reduce by 3, this is once by 3, this will be 3. So m alone will be as good as a third. So our recurring decimal, we can say even therefore 0.3 recurring is equal to a third. What gives us a third? So this is our first example.